In this video tutorial, we shall see the logic as well as the program to find either the largest number or the smallest number in an array of unsigned numbers. So we shall see the logic for largest, and the same program you can modify for the smallest number. Let us first see the logic of the program. Let's say I have some array of numbers 5, 2, 6, 1 and 3. So the largest number here is 6. So this is what is the expected output, right? And the block size here is n is equal to 5. Now, what is the logic? The logic is we compare two numbers at a time, right? And we will fix one location wherein we will store the largest number, okay? And that location will be the accumulator, okay? So we'll make sure that when we compare two numbers, whichever is the largest number, that will be stored in the accumulator, right? So we'll start with an assumption, okay? Because we have not done any comparison, we will assume the first number to be the largest, and we will copy this to accumulator. So accumulator contains 5, right? Now we shall do the first comparison, right? That is compare 5 and 2. So when we compare 5 and 2, we had initially assumed we had initially started with the first byte as the largest itself. So when we compare 5 and 2, we see that accumulator already contains the largest. So we don't update, and still accumulator contains 5, right? Next, we will compare 5 and 6 now. So when we compare 5 and 6, we find that 6 is largest. So that's why we need to update the accumulator. Update the accumulator with the largest number. So here we will copy, update the accumulator with 6 now, right? Next, we will compare the contents of accumulator, that is 6, and the next number, that is 1. So in this case, we see that accumulator contains already the largest number, so no updation. Next, I will increment the pointer. Accumulator still contains the largest. This I will compare with 3. So 6 is still the largest, so here also I don't need any updation, right? So you see that if there are n numbers, I need 1, 2, 3, 4. So n was 5, so I need 4 comparisons. So in general, if there are n numbers, so I need to perform n minus 1 comparisons, right? And I start with the assumption that accumulator contains the largest. And the accumulator content I will compare with the all other bytes. And whenever I find a largest, I will update the accumulator. Or else I will simply skip and go ahead with the next number. That's it. Now for comparison, I will use this instruction. Compare, jump and not equal, right? So we have got 3 variants of this. One of the variant is compare jump not equal to a comma. I cannot have a register here. I can have a direct address. And next the label, right? So what this instruction does, it compares two numbers. So accumulator is the destination here, and this is the source, right? And it affects the carry flag in such a way that if the destination is greater than or equal to the source, then carry flag is 0. It means already A contains the largest or it is equal to the source. The other case is if the destination is less than source, it means carry flag is equal to 1. It means destination is smaller than the source. So therefore, carry flag will be equal to 1. And while doing so, it does not affect the destination. The contents of the source as well as the destination remains as it is. Okay. So later we can check out for the carry flag. Right? If carry flag is 0, accumulator already contains the largest, so I need not update the accumulator. Whereas after comparison, if carry flag is equal to 1, it means I need to update the accumulator with the largest number. Right? So this is the logic. Right? So we shall write the program for the same, that is largest of a number, or just in an array of unsigned numbers. Fine. So first I need to initialize the array size. So I will say move R3 comma hash 5. So this is array size, right? But I have to do n minus 1 comparisons. So I will say decrement R3. This is n minus 1 comparisons. Then I had to initialize a pointer to memory location 30h, move R0 comma hash 30h. Right? So pointer to start address. Right? And what did we say? We will start with the assumption that accumulator contains the largest, right? So I will copy move a comma at the rate of r. I don't know, but I have to start with, right? So largest will be always in register A. That's what is my assumption. Now this I have to compare with the next byte. So for that I have to increment the pointer. So increment R0. Right? Then I have to use this format. Compare jump not equal to a comma direct. I cannot use this. Compare jump not equal to a comma at the rate of R0 next. I should have used this, but this format is not allowed. So you can see expression does not match. Okay. Whereas this can be a memory location. Let's say it is 60H. See, now this works, right? This is some other error because I have not said where is next, leave it. So that's why whatever R0 is pointing, I will copy to 60H. This I am doing because the instruction supports only this format. Move 60H comma at the rate of R0. Right? Now what I am doing is I am comparing the numbers now. So currently accumulator contains 5. I have incremented the pointer. So that too I have copied to 60H. Why this was needed is because of the reason that this instruction does not support indirect addressing here. Okay. So the next will be here itself. Now after this, what are we supposed to do? We are supposed to check the carry flag. If the contents of accumulator is already greater than 60H, carry flag will be equal to 0. So we need not update the accumulator. But if the contents of accumulator is less than 60H, carry flag will be equal to 1. Then we have to update accumulator with the largest. That is, whatever is in 60H, that will be copied to accumulator. So I will check for the carry flag. Jump on no carry, right, to skip. It means there is no updation needed. But if the carry flag is equal to 1, I will say move a comma 60H. It means what? Update register A with largest. Fine. And this thing we have to repeat for n minus 1 times because we have to do n minus 1 comparison, right? So for that, decrement jump on non-zero R3 comma repeat. and this skip label will come here, right? And where will be the repeat? Repeat will be at here. Fine. So we shall execute this and we will check out. Okay. Let's say I have given 1, 3, 2, 5, and then 6. Right? Let's analyze. So I have 5 data. I have initialized 5 data here. So R3 contains 5, but I have to do n minus 1 comparisons. So I am decrementing R3. So R3 is 4 now, right? And I'm initializing pointer to memory location 30H. I'm copying the first data, that is whatever is in 30H, it means 1 will be copied to accumulator, right? Now we'll increment R0. R0 is pointing to the next location. So what do we have in next location? 3. So that 3 I'm copying to 60H. Okay. Now I'm comparing 1 and 3. Accumulator contains 1, 60H contains 3. So definitely contents of accumulator is less than 60H. So what do you expect now? The carry flag will be equal to 1 because the destination content is less than the source content. So if carry flag is 1, it means accumulator does not contain the largest and it has to be updated. So that you can see now. So you can see after the execution of this instruction, carry flag has become 1, right? So this condition will fail and will come to the next instruction, 60H, which contains 3. Now that will be updated to the accumulator, right? So this way we ensure that accumulator always contains the largest. So we have finished the first comparison now, right? So we shall go to the next now. Increment R0 means now R0 is pointing to 32H, and in 32H we have the content 2. So that will be copied to 60H, right? Now you see accumulator contains 3 and 60H contains 2. So accumulator already contains the largest number. So carry flag will be equal to 0. So check out here. So carry flag is 0. So this condition will be true. Jump on no carry. It checks whether the carry flag is 0 or not. So carry flag is 0. So you need not update the register. So it will simply skip and it will go to the next byte. Now it is pointing to the memory location 33H, right? Which contains a data of 5, right? Now accumulator contains 3 and 60H contains 5. So definitely accumulator contents are less. So carry flag will be equal to 1 and you should update accumulator with the largest. So accumulator contains 5. In the last comparison, 6 will be copied to 60H. Accumulator contains 5. 5 is less than the contents of this 60H, that is 6. So that's why I need to update. So accumulator will be updated with the largest number. So at last, if you see the accumulator should contain the largest number. That is nothing but 6. Fine. So this is the logic of finding the largest of a number. And to find the smallest, the only thing you have to do is here, instead of jump on no carry, make it jump on carry. That's it. Right? And we will assume that accumulator always contains the smallest. That's it. Okay. I will quickly run through. So the only change you have to do is here. Right? So let me have 9, 1, 3, 1, 6, So I'll quickly run this. At last, accumulator should contain the smallest number, right? So check out the contents of accumulator. It contains the smallest number. Fine. So this is the logic and the program for finding largest or smallest of a smallest number in an array.